Hey, this is Dr. B, and let's have a look at unit conversions. Now, if there was ever a topic to get right, this is it because it shows up across almost all the chapters in this unit, and it also shows up in many other subjects, physics, biology, mathematics. So let's have a good hard look at unit conversions. Let's start with something we're familiar with. Let's convert 7.25 into quarters. Now you probably know that that's going to be 29 because there's 4 quarters for every dollar plus the extra one, so 28 plus that other quarter makes 29 quarters in $7.25. Good. But we're about to get to problems like this one down here that are going to be unfamiliar to you. So let's make sure we have a systematic method. We know when to multiply, we know when to divide, we know when to do both. We'll start with what we're given, which is the $7.25. We'll estimate that it takes one step, since 4 quarters is a dollar. We'll write the final units at the end, meaning that it's going to equal a certain number of quarters. That's called our setup. We'll multiply using our conversion factor, 4 quarters per dollar. Why didn't we write 4 quarters on the bottom and dollar on the top? Because the units would be messed up. Dollars divided by dollars equals 1. Quarters is the only unit left standing. If we had flipped it around, it would have been dollars squared over quarters as our final unit, and that is not right. So multiply it through, and in fact, you're right. Cancel your units nicely. Teachers love that. You get your 29 quarters. Here's one you probably can't do in your head. We've got 1,285 quarters in a bag. How many dollars is that? Well, I guess it's going to be 1/4, right? We're going to divide it by 4 since there's 4 quarters for every dollar. Sure, and most students like to just divide by 4 and get their answer, but don't do it. Start with what you're given. Estimate that it's one step. Get quarters on the bottom, and there's 4 of them per dollar. Yep, we do divide by 4. Yep, the units cancel nicely. We know we're going to be doing it right, and it turns out to be $321.25. Here's a two-stepper. We're going 65 miles an hour. How many meters per second is that? Well, here's how we convert from miles to meters. There's 1609 meters in a mile, and we can go directly from hours to seconds, noting that there's 3,600 seconds as an hour. So what do we start with? Always start with what you're given, the 65 miles over hours. Resist the urge to draw it diagonally. The units won't be as clear. Draw it with nice horizontal lines so you can cancel nicely. For here, we'll go from our miles to our meters, and there are 1609 meters in a mile. Miles will cancel. For the hours, it's okay that it's far away. An hour is equivalent to 3,600 seconds. The hours cancels, and the meters cancels. What's left? Meters per second. It must be correct. Students have a really bad habit of not putting any units here. They just write 1609, they write 1 over 3,600, and they make careless errors. Avoid it by doing this systematic method. That's 29 meters per second. Okay, if you can solve this problem, you've got this down. There's going to be some unfamiliar units here. Don't let it worry you. And as a big hint, you're going to see per written a bunch of times. See that? 3 times there. Per means draw a line. Grams per liter. That means grams over liters. Most gases occupy 24 liters per mole. That's 24 liters over moles. At room temperature, given that carbon dioxide has a molar mass of 44 grams per mole, that's 44 grams over moles. What's the density? That's what they're going to, of carbon dioxide at room temperature in grams per liter. We start with, that's right, what we're given, which is the 44 grams per mole. After all, it does say given that. You could, of course, start with 24 liters per mole and run it through that way. So we'll start with what we're given, the 44 grams per mole. We'll assume it's a one-stepper, and they want something in grams per liter. Fine. Looking at this, you should see that grams does not cancel. We want to keep it there. But we do want to convert moles into liters. To do that, moles better go up here, since a mole over mole equals 1 and it cancels out. And we better get liters on the bottom. Well, we got the perfect unit conversion for that, right? Look at that. 24 liters is a mole. So make sure you do it in the right order. By the way, when you start with what you're given, don't be surprised if you accidentally wrote it upside down. These can always be flipped over. A mole has a mass of 44 grams, just like 44 grams is a mole. Okay, so cancel your units, knowing it shows you did it perfectly, and we end up having a density of 1.8 grams per liter. This is an introduction to unit conversion.